All right. Okay, so here we go. So we got Unit 3, Lesson 5. So it's kind of intro to radicals. Okay, so we're going to talk about radicals a little bit. So obviously, or maybe not obviously, excuse me, I can't say that. When you're talking about algebra and you're talking about opposites, you have plus and minus are opposites. You have multiplication, division is opposites. Then you have squaring and square rooting are opposites. So when you know, like when I say 3 squared is 9, the opposite of squaring something is square rooting something. Okay, so they undo each other. They're opposites. Okay, just something to keep in mind so that it's not completely new because we've learned squaring before. We've done exponents in grade 9. Okay, so square roots. All positive numbers have 2 square roots. One, a positive number, and the other negative number. Okay, the square root is called the principal square root. So, for example, 16's roots are 4 and negative 4. Because negative 4 times negative 4 is 16. Positive 4 times positive 4 is 16. Okay? What this is saying, I know it's kind of confusing. I don't really like how the book does it. But what they're saying is, if it's asking you to evaluate the square root of 16, it's just 4. So it's asking, hey, what is square root of 16? You can say just 4. You don't have to say both. Okay? All right. And then the square roots of non-perfect squares are irrational numbers. So the square roots of 17 are root 17 and negative root 17. You can just leave it like that. That's the plus or minus. Okay? So was there questions on that? It's kind of basic, but it's important to understand that going forward. So is there any questions on why? Do we understand why it's plus or minus? It's plus or minus because if you do a square root is something times itself. If I go negative 4 times negative 4, I get 16. If I go 4 times 4, I get 16. So they get the same result and they're a positive and a negative. Okay, same thing here for root 17. Okay, the square roots of 17 are root 17 times root 17 and negative root 17 times negative root 17. Okay, the reason being 17 times 17 is 289. Did I say plus? 17 times 17 is 289. The square root of 289 is 17. These would both equal 17. Okay, all right, so now cube roots, they're a little bit different. Square roots, you can't have any negatives in the radical. You can't get any, like I can't square root a negative 4. Because nothing you do, if I square something, if I square negative 2, will I ever get a negative 4? No, because a negative times a negative. Every time you square a number, you will get a positive answer. 6 times 6, 36. 4 times 4, 16. Negative 2 times negative 2, positive 4. But cubing is odd. So if I cube a number, if I cube negative 3, I will get negative 27. So negatives are okay with odd roots. So cube root is odd because it's a 3, so negatives are okay. So if I cube root 1,000, it's 10. You can use your calculator to figure that out, or just know, we should know that one pretty well from our conversions. It's just 10 cubed, right? And then this is the kind of the new one, or maybe something to make you scratch your head a little bit. Cube root of negative 27 is a negative 3. Because negative 3 times negative 3 times negative 3 equals negative 27. Negative 3 times negative 3 is 9. 9 times negative 3 is negative 27. Wow, that's really bad handwriting. Okay. All right. Any questions on these two? About why cubes are negative? Why that's okay? Okay. All right, so the cube root of a non-perfect cube is an irrational number. Okay, so again, if it's a number that can't be broken down or come out smooth, like cube root of 49, there's nothing times itself 3 times it's 49, so it's an irrational number. Does that make sense? So when you have stuff left in the radical, like cube root 11, okay, that's going to be irrational. It's going to be going on for a long time. Okay, let's get going here. Let's get to the warm-up here. All right, so other roots. Complete the following statements. 4 times 4 is 16. So the square root of 16 is 4, or root 16 is 4. So we're filling this out together now. Okay. 5 times 5 times 5 is 125. So the cube root of 125 is 5, or cube root 125 is 5. So just knowing that 3 5s multiplied is 125, so going the other way, cube rooting that is 5. Okay? So if you put your calculator right now, light bulb, Joe? Oh, it just sounded like the light bulb came on. Like, oh, yeah, okay. Yeah, we'll get to it. We'll get to it. So, oh, you mean the calculator or just in general? Just in general? Well, we'll do it. So cube root 125, if you put your calculator, let me finish this. If you do cube root 125 on your calculator, you will get 5. Okay? So now, fourth root is the same concept, 4 numbers multiplied. So 2 times 2 times 2 times 2. 2 4 times, not 2 times 4, 2 4 times is 16. So the fourth root of 16 is 2. If you put this in your calculator, it's 2. Okay? How do you put that in your calculator? Good question. That's what Breezy just asked me. You go to your calculator, just have it clear, just a clear screen, and type in a 4. And then math, and I think it's 5. I could be wrong.
Yeah, there's actually a page in it.
Oh, okay. Cool. So then you get this right here, and then you put 16, and then it kicks out a 2. That means fourth root in your calculator. We good? Okay, and then what's this one? 10, 10, 1, 2, 3, 4, 5, 6 tens. So the sixth root of 1 million is 10, or sixth root of a million equals 10. Sorry, I kind of ran out of room there. Just writing the same exact thing we just did from above. Okay. All right, so let's get back to kind of going around here. So Tatum, what's the square root of 49? Oh, I erased it. Dang it. 7, good. And remember, I expect you guys to know your perfect squares memorized all the way to 225, which is 15. Okay. Cube root of negative 64. Taylor, what do you think? Negative 4, good. Okay, and if this is a positive 64, then it'd be a what? Positive 4, good. Okay, fourth root, Brand, of 10,000. No? Fourth root of 10,000. Oh, did you? I think you might have did 4 times the square root. Yeah. You have to hit that one. 5. And then see how it's up there now? So it's 10. Okay. Good mistake there. Gotta make sure that 4 is in the index, it's called. Okay, fifth root of 1 over 32. 1 over 2? Okay, good. It's 1 over 2. Thanks, Janae. Okay, now how you can do this, now you still put in your calculator, okay, but you can also do it in your head. Fifth root of 1 and fifth root of 32. Fifth root of 1 and fifth root of 32. When you're doing a cube or you're doing a radical of a fraction, you do it to the top and bottom. Well, fifth root of 1, that's kind of silly. It's just 1, because 1 times 1 times 1 all the time, right? So that one's simple, 1. And the fifth root of 32 is 2, which, come up here, the fourth root was 16. Well, what's 2 times 16? That makes it the fifth, right? So that's kind of where it comes from, okay? And you can still do this off your calculator. You don't have to memorize fifth roots. I'm not asking you to memorize that. I just really like to explain things in terms of number sense. I want you guys not to be 100% dependent on your calculators. I'd like you to think, okay, 32 to the fifth root, 1, that's got to be a pretty small number. Anytime you times something by itself 5 times, you're going to want to start with something small. So right now, Brandon, do me a favor. What is 5 cubed? Just put 5 cubed in your calculator. You can use your calculator for that. What is 3 to the fifth? Not 5 cubed. 3 to the fifth. Just put 3 caret to the 5. It's 243. See how much different those numbers are? 243 to 32. So if you're in a fifth root, you better start small, like number 2. Okay? All right, good. Fourth root of negative 16. What do you think, Jose? Fourth root of negative 16. Okay, you would be right, but what kind of number is this, even or odd? Anytime you have an even, there's a negative inside, you reject it. You say, no thanks, can't do it. That's why your calculator said error. No, there's just no answer. It's not possible. Yeah, so if you put in your calculator like Taylor said, it'll say error. You can't do it. So this is a great point, okay? And there's no answer. Whenever you have an even root of a negative, it cannot be done. Yes, if it's a 3, you could do it. Odds, you can do negatives. Evens, you can't. Okay? Now, if it was a positive 16, now let's watch. If it's a positive 16, we already did that, didn't we? Right here, right? Positive 16 was 2. But this is why. We can never get a negative here. If I change them to negative 2s, look what happens. What's a negative 2 times a negative 2? 4. Negative 2 times a negative 2? 4. I get back to 16. I will never get negative. That's why we can't do it. Okay, makes sense? All right, and the last one, Xander. What's up? 10? So cube root 125, we did that up here, so that's 5. When there's a number outside just hanging out, that means what operation? Multiplication. So it's 2 times 5 is 10. Good job, Xander. Want me to cover there, Patty, on the back? Yeah. That'd be very relieving. Thanks. All right, next page. All right. Okay, so this is what we're talking about. This tells you how to use the math number 5 on your calculator to do roots of bigger numbers than 2 and 3. Okay, so use calculator to calculate and evaluate. So go ahead and practice these real quick on your own. I'll give you about 30 seconds, and I'll just write the answers up here so you can check yourself. Okay, all of these, put in your calculator. All right, and then just as you get going, so Chris, when you get A, let me know. Alex, you can help me with B. Breezy, C, and then we're back to Tatum for D. And then Taylor for A on 3. Brandon, B. And Janae, your part C on number 3. Okay, you ready, Chris? Are you first? Good. 4. Okay. -3. Good. -45. Good. Tatum. 1.2. Good. Or 6/5. Good. Okay. And Taylor? Did you say 2 or 3? Good. 2.63. Good. Brandon? Good. And Janae? 6.67. I think did you divide it by 3?
Do you have to do like 2 times?
You need to go in your calculator 2/3 with the parentheses, and then do parentheses 4th root of 1,000.
Oh, is that 1,000? Oh, I thought it was 10,000.
Oh, okay. Yeah, so it should be 20.
0.66.
You should get this.
Oh, what?
20 over 3. It should be.
Oh, I tried the cosine. I don't know what I was doing.
Okay, that's all right. Because 4th root of 1,000 is what? It's not quite 10. Yeah, it's gonna be small. So yeah, that's about right. Okay. All right. Here's some important stuff. This is for your future. Your first section, just heads up, in Math 20 will be radicals. That's your first test in Math 20. I would know that, right? So, different radicals. These are all examples of radicals, okay? And this is important that you understand what the different terms are, okay? The index is the root number, okay? Cube root, 4th root, that's called the index. The radical sign is just the sign itself. The number inside is called the radicand, okay? It's called the radicand. The whole thing is considered a radical. Okay, those are important vocab words. There are things to know. So index is the cube, square root, etc. Inside the radical is called the radicand. The whole thing is a radical. All right, our last page here. Example 4. Identify the index and radicand of each of the following. So we're on Josie. So what's the index of A? Good. And Xander, what's the radicand? Good. And Alex, what's the index of B? Good. If there's not a number there, it's assumed to be a 2. Radicand, Chris? Good. Okay, index, Breezy, 3. And radicand, Tatum? Good. All right, fair? Fair. All right. Okay, so number 2, recall the following results from lesson 4, assignment question 10. Root 9 times root 4 is equal to root 9 times 4. Okay, so multiplication is okay with radicands. You can multiply radicals if they have the same index. These are both 2's, right? But you cannot add them. You cannot add them. Do you guys hear me on that? Because everybody tries to do that. You cannot do root 9 plus root 4 is 13. And here's the proof. What's the square root of 9 equal? 3. What's the square root of 4 equal? 2. What's 3 plus 2? 5. Square root of 13 is not 5. Does that make sense? That's the proof. Okay, here's the proof that this does work. We already know that's 3 plus 2, right? 3 times 2, that's 6, right? What's 9 times 4? What's the square root of 36? 6. So that's the proof that it does work with multiplication. Okay, and then just like with everything, division and multiplication go together. You can divide. Okay, you can't subtract. Okay, questions? What's that? No? Okay, the addition and subtraction will make sense when we get to that, so just pause on that. If you're like, wait, I don't get this addition and subtraction, that's actually the more complicated. We're going to get to that in a second. Or maybe next lesson. I haven't looked this far ahead yet. Okay, so then in general, here's your rules. All right, so let's get these last examples here, and we'll be done. All right, so state whether each statement is true or false. So where are we at? Taylor? Okay, is A true or false? Can we multiply them? What's 6 times 3? So it's going to be true. Because we can do that. They're just asking you, can I do this or can I not? Okay, Brandon, true or false? True. Root 20 divided by root 10. Well, 20 divided by 10 is root 2. That's true. We can divide them. That's okay. Okay, and Janae? False. We cannot add them. That is not interchangeable. Good. Write the following as a single radical in the form of root x. Okay, so once you write it, just do the rule. Okay, so Josie, part A. What's root 8 times root 3? Well, just usually got to do what's 8 times 3? 24. That's, it just wants you to write root 24 because it wants you to keep it as a radical. It doesn't want a decimal. Okay. Xander, part B. Root 21, good. Okay. Alex, part C. Good. Ooh, tricky one. Okay, so part D, Chris. Well, just do this real quick. What's the square of 100? So just think of it like this. Good. Does that make sense? Just do this. We're just doing one piece at a time. Okay, now they want you to go backwards. Okay, so Breezy, I want you to set what's the product of 77? What's two numbers that multiply to get 77? 11 times. So it would be root 11 times root 7. That's what I want you to do. Okay, and Tatum, back to you. What's the product of 27? Not 7. 3 and 9. 3 and 9. Okay, and 40, Taylor? 4 and 10. Good. Okay. All right, that's it. Today is your lesson for Mark for this unit so far. We haven't done one in this unit, so the numbers, I think it's just 1 to 10, I believe. Look on your homework sheet. There you go. That's what you're doing today. Okay, good deal. You have the sheet.